didn't want to initially give a talk, but like I have realized that it's been actually today exactly 10 years since I proudly announced the Autoformalization project at Kickham. So in, like, I think it's been 10 years. Yeah, so today is July 10. So, I should probably say a bit of a history, but like I didn't even know that Michael would schedule me for today. I just and,
prophecy is a good quality.
And I just wanted to say a couple of words about like this whole landscape and what I think about like the past, present, and some surprises that were on the way. And I should say that I will not speak like too much about LLM-based formalization because we have Lambda for that, and for conjecturing with LLMs we have more talk. I think so. Don't expect some craziness. I tried to sort of, like I took it as an opportunity to slightly sort of organize my mind format in the history of all these attempts, and also why I sort of felt that things weren't going in the right direction when I declared this project 10 years ago. And like you can obviously correct me, I don't claim super historical expertise on this. So you have these, I don't know, like 10 to 15 events, I would say, in the history of like sort of human-friendly, automated, maybe formalization. Starting really with Jaškovský's work on natural deduction, which is very much sort of embodied in the design style. And I tracked the first thing into John McCarthy, and I think Paul Abrahams was his PhD student, but correct me if I'm wrong, if any of you remember the history. Where like he really thought that he would be checking natural language textbooks back in 1962, 1963. So these pioneers, they were pretty crazy, right?
Can I add one thing on that one? I mean, people don't mention here the student program of Danny Bobrow. Was doing this other more between informal and formal. In 1964 is his PhD thesis, so it's kind of just.
Yeah, so like I said, I don't claim any completeness. I also think that Andrei could say, and his seniors from Kiev should it's really some evil time here. A lot of stories, and we had it 10 years ago in the Iceland when Andrei Triblets died, a bit about the SAT system developed by the Glushkov team. And like that was very much parallel, I would say, to this John McCarthy development in the West, and is very unknown still, I would say, so like that. And then obviously we have Andrei Triblets getting to 1973, and then like that's one of the projects that still lasts. I would say, so these are the things, like for example, Andrei was sort of initially some sort of a linguist / AI guy, but he quickly sort of went with this sort of Abraham's conclusion that checking like the full natural language is too crazy, that we don't have the tools for that at the time, so he really went in this direction of controlled natural language. Then I don't know much about Donald Simon's PhD thesis, maybe Shankar, yeah, because this was, I think, under Woody Bledsoe, right?
Yes.
And that again seems like a very amazing.
Donald was one of my mentors, actually.
Yeah. So that was again like this very direct attempt, like right a parser for like controlled or maybe even like unlimited natural language manually, right? And try to proof check it with some manual written theorem proofs.
So he was working on Lebesgue's number theory book.
So then, like obviously everybody knows Leon-Port, but it's just structured proofs. I didn't know much about how Arne got into grammatical frameworks. And my estimate is that it's 1990s onwards, but like then you know at some point Macarius rewrote Isabel basically, right? Like the Mizar people are joking that it's just Mizar, right? And I think the big thing which I learned from the Mizar guys is that you shouldn't try to do some sort of natural language parsing, like Andrei Trublet was extremely skeptical about it because he knew the work of Klaus Sen, which was done, I don't know, maybe Michael knows more about it because this was done in the Omega group.
No. What in Erlangen?
Oh, in Erlangen, but he did work with Omega. Spaß, ATP,
We did work with lots of things, but
okay.
not
Not really the Omega.
not
Okay.
related to my group.
Okay. So I would say this is probably very much worth reading because it's a big exploration. Can we do this stuff manually? And like I said, like when I started to look at Mizar for other reasons, basically to steal this data set for machine learning of formal theorem proving, they were extremely negative about trying this sort of automated for formalization. And like then again, there is Andrei working on SAT, but I think it has always been like kept in the controlled natural language domain, right? Like it's never. And then there is Peter, and then there is Mohan, right? And with Mohan, I talked with Mohan back in 2008 when I visited Larry, and I was both impressed and annoyed because on one hand you have this very smart guy, and on the other hand he again wanted to do it manually, like he wanted to write manual parser. so it really at some point I said like no we have to do it differently. So back in 2004, when I was still stealing this Mizar data, they actually did formalize this compendium of continuous lattices from like 60% already by the time. And like at that point, it was so crazy for some people to believe that we could try to like statistically translate LaTeX to formal language, that actually they did give me the LaTeX sources, but I haven't used them for like 10 years. And like then, I would say basically for 10 years, nothing was happening. And I really started to like, will I die and people will be still writing like manual parsers? Like, is this the like Piotr Rudnicki at some point had this interview in some Polish newspaper saying in 300 years we will formalize mathematics. So like, okay, well. so yes, I simply decided that even though we have done very little, we simply have to declare this project that like we will be doing what, for example, Google Translate was becoming very good at the time. And this was before they actually put language models into Google Translate. And that's basically some sort of statistical machine translation and combinations with all the stuff, semantic weapons that we have, like type checking, theorem proving, etc. So I in my mind, like there are like a bunch of things that somehow interact together, and like today, like everybody could see large language models will do it all, and we will fully translate natural language to formal proofs. But like you have just seen, and I know Stefania's talk that like we are still struggle with large language models, and I guess we will see more talks about that. Then there's this controlled natural language, and I think it may be like a very important weapon So for example, last year we did a very small project on common sense reasoning, and what turned out to be like a very, very good trade-off was to, if you have natural language, ask large or small language model to simplify it, to split it into small sentences, make them simple, like remove like the fancy vocabulary. And once you have it, it's sort of approaching the controlled natural language area, for which you can even attempt to like force something like GF or some Fortel or MapResh, etc. So I think one thing that we should be exploring is like at least with today's generations of the statistical machine learning tools, at least my experience in the last 10 years has been that some tasks are simply too ambitious. Like you shouldn't go, for example, for some fully elaborated Mizar text from LaTeX, when you can go from the unelaborated Mizar text, where, for example, the hidden arguments and the type are added then by the elaborators. So if you can sort of very much simplify the task that you are giving to these statistical methods, the whole pipeline becomes better. So I would say like one note like about how these things can interact is that like we are not crazily ambitious, and we will basically have these for example use of NAPROSH, right? Like NAPROSH in the middle or something like that. Another corner, and again, like people today, like with the sort of lean revolution, like several people ask me privately, could you do, or ask Thibault, could you do a formal-to-formal translator from, I don't know, lean to cock, right? Like we want to steal Mathlib because it's big, etc. So again, like, so for example, Thibault did like these pretty surprising, I would say, alignments, sort of statistically, semantically between different proof libraries. And you could sort of try to somehow, for example, do the formal to formal, like if you are aiming for some crazy future where we will be very easily translating from Isabel to Lean to Mizar to whatever. You could say that this will all be done by statistical machine translation, but again, like for example, Mario has this Lean 3 to Lean 4, right? And that could probably be extended to, I don't know, Lean to Calc or Calc to Lean or whatever. So again, like I'm somehow seeing this thing as some part of this sort of design space where some of it, like GF, right? Like we could have like GF for, I don't know, Mizar to NAPROSH, right? Or NAPROSH to Mizar, whatever. So again, like, do we have to do it all by like large language models? Or for example, could we for example use the AI that we have today to automatically design these translations, right? Like to for example have a GF translation system that is sort of explainable and goes back and forth. Yeah. So I guess these are some sort of 3 to 4 things that are somehow in this area, and I will not go through all the slides, don't worry. But like I'll just say like what let's say in these 10 years have been probably the biggest surprises for me. So I guess maybe the first one, and I can to the people who haven't seen it, but I think many of you have seen it, show you this sort of probabilistic context-free grabber that we did as the first approach in 2015, where it's actually this this demo, which only takes 1 minute. So I think many of you have seen it multiple times. So you sort of write an informalized statement, and then you, on the fly, today we would call it retrieval augmented generation, create a grammar, probabilistic context-free grammar, which is sort of parsing the informal statements and type checking them, like in the probabilistic context-free parser. There is the whole Hindley-Milner type checker, and well, some limited version of it. And then you are sort of sending it to basically to the holy hammer that we created at that time. So so this was go back. This was probably the first surprise that even though this was produced by informalization, like it was sort of synthetic data, etc., the grammar that we created completely automatically, like just from the corpus by the probabilities from the corpus, was really very good in this task. The type checking methods that were put inside the PCFG parser were extremely useful, like they were really pruning the junk very efficiently. And then what also surprised me is that like these things were sort of occasionally coming up with new conjectures that we could prove, for example, by the hammer. So for example, it would take the informalized statement, interpret it differently, and then it could actually prove it. So instead of a theorem for square matrices, we would prove a theorem for rectangular matrices just by the wrong parsing. So that was one surprise. And I somehow still think that like these, and maybe that's some sort of a bridge between what Arne was showing and Peter was showing and what we will see with the large language models, is somewhere in the middle. Well, like it is statistical, it is sort of initially produced by a machine, like the parser, but it's sort of in the explainable realm. So maybe once you generate the grammar from some corpus, you can go sort of in the Arne that direction and somehow tweak the grammar to your liking, maybe limit it, get rid of the worst possible cases. And I think maybe today we could do this even like with the bigger guns that we have in the LLM, like take, I don't know, Isabel and ask for a reasonable grammar from that. So I think there is this space of solutions that are explainable. Maybe they have some probabilistic thing to it, but they are not as crazy black box as the sort of full-scale neural thing. I probably mentioned the Thibault thing already. Oh, I didn't want to have the slide, sorry. Yeah. So what also very much surprised me, and that may be sort of a new thing for people who don't know it. Yeah. So the Thibault Gautier, before he got into Holy Hammer, or maybe simultaneously, was working on alignments between libraries which weren't like purely statistical. They were really like a nice combination of what you could say statistical and semantic methods, in the sense that you basically take two libraries like whole light, whole for, Isabel, etc., and you characterize each symbol by the list of lambda abstracted properties that hold about that symbol. And you do some sort of reasonable probabilistic weighting, like TF-IDF, like if some property is valid about every symbol, it shouldn't be like too important as a characterization of the symbol. And just by doing this and having some sort of fixed point algorithm, he could really surprisingly well align multiple proof assistant libraries. And again, like there is this aspect of like fine. Maybe today, for example, we have this graph neural network by Miracle Sharp, which is like fully signature independent, and it's very good in understanding transferring theorems from one domain to another. But like maybe we could have as a complement to all of these sort of either manual or like very neural black box methods, more of these transparent semantic methods, which sort of you cannot really see so well in the sort of neural language modeling world. So if you don't know it, then I would recommend it to all sorts of people interested in this space to look at it. I would say at some point, like with Schoenbank, we did this first basically neural autoformalization on the Mizar synthetic data set. And this was really I had a couple of surprises in my research life so far, and this was definitely ranking pretty high, because I gave Sean a data set of 1 million LaTeX to Mizar formulas that were sort of synthetically generated, and he started to play with different neural architectures, and the performance went from crappy and that's what I expected to very, very good. And like at that point, like this was 2018, I was sort of sold. I saw that the neural people, I know that today many people are annoyed by the neural people, by the hype. I am also annoyed. But like at that point, I saw that there is real, very valuable research done here. That, for example, the introduction of attention already in LSTMs or bidirectional LSTMs makes huge performance jumps in these neural architectures. So I would say it's very hard today to maintain some balance of your mind. But if you if you try, this is after the spam filtering. This is really like a very interesting landscape of solutions. Typically, you need to try it yourself. You sort of can't believe what some high-profile papers say, because there is really a lot of corruption, like training of testing data, etc. But like really some of these techniques that people develop in language modules are extremely powerful. And yeah, okay, let me skip to the end because Valeria is nervous. So I will be at AGI 1 month from now, and I'm supposed to tell these AGI people what's the future of formal mathematics. And 3 years ago, I sold them really this vision. Like it was like what Johan Kummelin was saying, that he's still talking to us in natural language. I think that this still really, I had these bets which I skipped with. I went back this Frake about how much we will autoformalize in how much time. But like today, I would be even like bold enough to sort of sharpen it by saying that like the combination of all these methods that we are seeing here, for example, in 10 years will really, like the way YouTube is now transcribing our talks into natural language, we will have tools that will be transcribing the math talks into, I don't know, approach, or maybe even lean, I don't know. Like, but I would say maybe the message is that I'm sort of very pleasantly surprised how the last 10 years developed, and I'm sort of very happy that the Kikan people sort of forced me to go there by basically telling me, yes, do this project. So that's